function that ensure constant supply of oxygen to our tissue and elimination of carbon dioxide to the environment. It involves the movement of air through the nose or the mouth into the lungs and diffusion of gases into the blood and body cells. This movement occurs due to pressure difference between atmosphere and the alveoli and partial difference of oxygen in alveoli and blood.
Level between sea level and high altitude. The concentration of oxygen in the sea level air is 20.9%, so the parcel pressure of oxygen is 21.136 kilopascal. The percentage of oxygen in air is constant at different altitude, but the thinner air means there is a less oxygen to breathe. The percentage of oxygen is the same level as the high altitude, which is roughly 21%. At the sea level, the air more compressible and the weight of all the air above will compress the air around us, making it denser. The high altitude barometric pressure may be significantly lower than at the sea level. The oxygen molecules are spilled further apart and lowering the oxygen content of each breath. It reduces the availability of oxygen in the air and the blood oxygen level decreases. The body will struggle to efficiently deliver oxygen to the tissue, muscle, and the brain. The body will make what range of physiological changes in order to cope with the lack of oxygen at the high altitude. Even though the air contains 2.9% oxygen at all altitude, but the pressure is low at the high altitude, make it feel like there is a low percentage of oxygen. Air molecules at high altitude are more dispersed. Each breath will deliver less oxygen to the body. Sea level, the partial pressure of oxygen in the atmosphere is 159 millimeters of mercury. It is higher than the partial pressure of oxygen in the alveoli and the capillaries, which is 100 millimeters of mercury. Due to the pressure difference, oxygen molecules from the atmosphere moves into alveoli and enters the capillaries. The amount of oxygen in capillaries increases until the partial pressure of oxygen in alveoli and capillaries are equal. The oxygen is then transported to the body tissues through the arteries to be used in cellular respiration. Meanwhile, at higher altitude, the partial pressure of oxygen in the atmosphere is lower compared to at sea level. 3,000 meters above sea level, it can drop up to 111 millimeters of mercury. This height, the partial pressure of oxygen in the air is still higher than in the alveoli and capillaries. As a result, oxygen diffusion from alveoli into the capillaries can still occur. However, since the pressure difference is low, only a small amount of oxygen can enter the bloodstream. This leads to lower amount of oxygen being transported to the body tissues. 5,000 meters above sea level, the atmospheric partial pressure of oxygen is only 85 millimeters of mercury. This level is lower compared to in the alveoli and capillaries. Hence, oxygen from the surrounding air cannot enter alveoli or diffuse into the bloodstream. Consequently, oxygen cannot be transported to the body tissue.
You guys wondering what is altitude sickness? So altitude sickness, which is also referred to as acute mountain sickness, describes the biological changes that occur as you ascend above sea level. As you rise above sea level, the air becomes thinner, air pressure begins to drop, and less oxygen is available when you breathe. Symptoms of altitude sickness develop 6 to 24 hours after reaching altitude more than 2,500 meters above sea level. and become progressively more severe as elevation above sea increases. Human life is not sustainable at altitude above 2,000 feet. One symptom of altitude sickness at lower altitude include loss of appetite, nausea, vomiting, exhaustion, dizziness, fast heart rate, headache, shortness of breath, and difficulty sleeping. Symptoms at higher altitude can be severe and if not treated immediately can lead to death. Serious symptoms of altitude sickness at higher altitude include the first one is fluid retention. Oxygen deprivation at high altitude causes cell and tissue to hold extra fluids. You may notice swelling parts of the body, including the face. Another one is high altitude pulmonary edema, which is known as HAPE. This dangerous condition occurs when fluid accumulates in the lung. HAPE causes congestion, coughing blood, extreme weakness, bluish tone in the skin, rapid pulse, and shortness of breath. The last one is high altitude cerebral edema, which is also known as HASE. HASE, like HAPE, is a very dangerous and requires immediate medical attention. Symptoms of HASE result from fluids build up in the brain. As fluid accumulate in the brain and push against cranial walls, neurological symptoms begin to occur. These symptoms include tiredness, fever, slurring speech, confusion, stumbling, blindness.
High altitude acclimatization is the process in which our body becomes accustomed to lower levels of oxygen in the surrounding air. This process can only take place gradually as you move up through various levels of altitude, spending time at each level before progressing upwards. So it is like if an individual hikes 3,000 meters above sea level, they need to stay there around 1 to 3 days, so they will become acclimatized to 3,000 meters. So if the same individual want to hike to 4 meters in above sea level, so then their body need to acclimatize once again. Do you understand? So our body will try to adapt with this higher altitude with many ways, which is the first one, our body will adapt by breathing faster and more deeply. The second one, our body also will increase its red blood cell count to allow the blood to carry higher amounts of oxygen. The third one is our body will produce a particular enzyme in greater quantity that causes oxygen to be released from hemoglobin to the blood tissue. Then, to properly acclimatize, you need to bear in your mind with all these factors, which is like the first one, you need to make sure you ascend slowly and gradually. You need to take time here. Second, you also need to stay hydrated to prevent any symptoms of altitude sickness. And the last one is, don't overdo yourself physically. So you need to make sure to rest frequently if necessary.
Generally accepted that heart rate at high altitude are higher while oxygen saturation levels are lower than at low altitude. In contrast, maximum oxygen uptake and endurance levels are lower at high altitude than at low altitude.